Hello, good morning. Today video 139. It is for BSc Part 2, Organic Chemistry, Paper 2, Unit 3. In continuation of aldehyde and ketones, today we will see Mannish reactions, Cannizzaro reaction, and reduction of aldehyde ketones to alcohols. Mannish reactions. The reaction of formaldehyde with an active hydrogen compound, a ketone like acetophenone, or a beta ketoester like acetoacetic ester or malonic ester, and a primary or a secondary amine to form a beta amino carbonyl compound. It is known as the Mannish base, and this reaction is known as Mannish reaction. See here, this acetophenone, formaldehyde, and dimethylamine. These three molecules will evolve water molecule and give us the Mannish base, and reaction is known as Mannish reaction. See how this formaldehyde, first it is reacted with dimethylamine, and it will give us this hydroxyanion plus this dimethylamine. And this dimethylamine carbocation it will react it with this anion, and this anion is formed with another this molecule of acetophenone by abstracting a proton, and this carbon anion it is obtained was reacted with this carbocation, and it will form this beta amino carbonyl compound, and it is known as Mannish base. Next reaction is Cannizzaro reaction. It is oxidation reduction reaction. Formaldehyde, which does not contain alpha hydrogen atom, undergoes self-oxidation reduction when reacted with 50% aqueous or ethanolic alkali at room temperature. One molecule being oxidized to form formic acid at the expense of the other, which is reduced to methanol. The reaction is called Cannizzaro's reaction. See here how this formaldehyde, when it is reacted, it will form this sodium formate and methanol. Similarly, 2,2-dimethyl propanol and aromatic aldehydes, which do not contain alpha hydrogen, also undergoes Cannizzaro reaction. See here how it is formed, and we will get one acidic and alcohol. See here, if this benzaldehyde, it will form this potassium benzoate, which is on hydrolysis, it will give benzoic acid, and second molecule is benzyl alcohol. Mechanism. This formaldehyde molecule will protonate and it will give this anion. It will rearrange and reacted with another molecule of formaldehyde. So it will give us the formic acid and this anion. which is further rearranged. So it will give acid and alcohol product. Now this proton is transferred to this anion and it will give us formic acid and methyl alcohol. And this anion, acid anion, will decompose with sodium salt and it will form sodium formate. Reduction. So aldehyde can be reduced to alcohols. Aldehydes are reduced to primary alcohol, whereas ketones are reduced to secondary alcohol, either by catalytic hydrogenation or by use of chemical agents like lithium aluminum hydride or sodium borohydride. See here, primary alcohol, secondary alcohol, and this is cyclopentanol will also convert it to this cyclopentanol. Benzaldehyde will convert it with the lithium aluminum hydride to the help of lithium aluminum hydride. It will reduce to benzyl alcohol. Acetophenone will reduce to 1-phenyl ethanol. 1-phenyl ethanol mechanism. How this lithium hydride will react with aluminum hydride and it will form lithium aluminum hydride. This lithium aluminum hydride decomposes into lithium ion and aluminum hydride. This lithium aluminum hydride will react it will form this complex and then 3 molecules of carbonyl. It will form this intermediate and then on hydrolysis it will form this alcohol and aluminum hydroxide, lithium hydroxide. Selective reduction. In case of alpha beta unsaturated aldehydes, lithium aluminum hydride reduces the double bond and aldehyde group, while sodium borohydride reduces only aldehydic group. See here, lithium aluminum hydride, it will reduce both the groups, unsaturated and aldehyde. Whereas sodium borohydride, it will only reduce aldehyde group. So it is a selective reagent. Sodium borohydride is a very selective. It will only reduce to aldehyde. Whereas lithium aluminum hydride, it will reduce both the group, unsaturated group and aldehyde group. So this is called the selective reagent. So thank you very much for today's lecture.